Hi, third grade. We are going to continue math instructional videos this week with investigation 10, which is on probability. So when we normally have an investigation, when we do it in class, it's different than a normal math day because on a normal math day, we'll have some instruction, we'll do some things together, and then you'll have time to work on your own. When it's an investigation day, we work mostly all together because we'll do a little work together, then you'll answer some questions. We'll do some instruction, you'll answer some questions. So this is likely going to be a longer video. However, this is also a shorter investigation than some of our other investigations. So we shall see. If you, when you made your geometric solids for our last lesson, if you listened in the video and you decided to make one of your cubes with dots or numbers on it to make a dice, you might want to grab that for this investigation. That's going to be coming up in a little bit. First, we're going to be working with the spinner though. And also remember, investigations have a lot more objectives usually than a normal math lesson would. So investigation 10 on probability, the objectives that we're covering are: use a fraction to describe the chance an event will or will not occur, find the probability of an outcome of an experiment, record the results of a probability experiment in a frequency table, record the results of an experiment using percent, and draw a graph to display the outcomes of a probability experiment. And in your work at home packet, it looks like this. It has 2 pages front and back, and then after that there is an extra frequency table. You're not going to see it if you look online in the Google slides. But if you have the paper packet or if you download the PDFs that were uploaded to our group page, there's an extra frequency table in there for you. We're not using that in the investigation today. That is just in case you would like to, after we're done with this probability investigation, if you want to do your own probability experiment and record the results, that's a place for you to do that. And if you wanted to upload a PDF of that and attach it to your Google assignment, you can get extra credit for that. So that 5th page or the 3rd page, depending on which side you're looking at and how you printed it off, that part is not something we're going to go over today. It's just a tool for you in case you wanted to do a little bit of extra. So it says focus on probability. Now, probability sounds very similar to another word. Probability, I think, sounds like the word probably. And if something is probably going to happen, that means it's very likely that that's how something is going to go. That's similar to probability because if you look in the math language sidebar right there, it says the likelihood of an outcome is called its probability. So I'm going to fold this up because I actually messed up on, this is my second video, so I already filled out part of this. Because I messed up on the spinner part. I had the wrong settings set. So we're going to try this again. So if you look at the very first part of this investigation, it says the spinner is divided into 6 equal parts. We have definitely seen that before when we've worked with fractions. So that should not be something new for you. Each part is called a sector. Each sector is 1/6 of the face of the spinner, and each letter is a possible outcome. So there are 6 different sectors. That's the piece that it's cut into. And when you spin it, if this was a real spinner, when you spin it, it's going to land in one of those sectors. And each one of those sectors has a letter in it. That's a possible outcome. So there are 6 sectors, but how many possible outcomes could we get on this spinner if this were a spinner we were using in class? How many different outcomes could we get? There are 3 sectors that say A, 2 that say B, 1 that says C. So there's actually only 3 possible outcomes, even though there are 6 sectors. That's the part I'd already copied down. The possible choices are A, B, and C. Now, A, B, and C are not equally as likely to be spun because there's more sectors that say A than say B, and there's more that say B than say C. So it says, on which letter is the arrow most likely to stop and why? So the arrow is most likely to stop on A because more sectors are labeled A. 3 of the sectors are A. Half of that spinner is A. So there's about a 50% chance that if I spin it, I'm going to get an A. And I'm going to illustrate that. This is the part I messed up on before, because normally I would have a spinner in the math drawer at school. We would spin this on the document cam, and then you'd be able to see it on the board. I didn't remember to bring home a spinner, but then I thought, I'll get a spinner from one of the board games downstairs. I'll change it to say letters on it. It'll be fine. But this is what happens. If I am spinning, and I'm holding it up so you can see it because I don't have a document camera here, just because of gravity, it's going to naturally want to point to whatever's at the bottom because the top part of the spinner and the one that I had is a little bit heavier. So I had to stop the video and try again. And I got an app on my phone that has the spinner on it. It has 3 sectors that say A, 2 that say B, 1 that says C. So it's just like the spinner that we have illustrated on the math investigation. So I'm going to click spin in the middle. And first time it gets an A. Then a B. A again. So I haven't gotten a C yet. I've gotten 2 A's and 1 B. I've spun 3 times. Now I got a C. So I've gotten 2 A's, 1 B, 1 C. Another B. Another A. Another A. So I did this 7 times and I got 4 A's, 2 B's, and 1 C. So which one did I get the most often? I got the A the most often because there's more A's. 3 of those sectors out of 6. 3 out of 6, that's the same as 1/2. Half of them say A on it. I got B more than I got C, which is what you would expect because I have more sectors that say B than say C. So number 3 in your investigation, I'm going to put this back on the clipboard, says list the possible outcomes in order from least likely to be spun to most likely to be spun. So which one of those has the smallest amount of possible outcome? The C, because only 1/6, its probability is 1 out of 6 chances that you're going to get a C. 1/6 would be the smallest fraction. The chance that I'm going to get a B would be 2 out of 6. And the chance that I'm going to get an A, which we already said was the most likely, would be 3 out of 6. So my least to greatest choices or probability would be C, B, A. A is the most likely, so it's going to be at the end if I'm going least to greatest probability. Now, number 4, which outcome is twice as likely as outcome C? Remember, outcome C had 1 sector. Which one had 2 possible sectors? Twice as likely. 1 times 2 would be 2. Which one has 2 sectors? B. So B is twice as likely to be spun as C. If the arrow is spun many times, then about half the outcomes are likely to be which of the following. So which one is most likely to be spun half of the time? Now, if this is a pizza, I'd say half of my pizza has A's on it. So A is the one that's likely to occur half the time. Now I'm circling this on my objective. When you fill this in on the Google Doc, you're going to have a box to type in your answer since you can't draw on the Google. if you're doing this electronically. If your arrow is spun many times, then what fraction of the spins are likely to stop in sector C? 1/6 of the time, 1/3 of the time, 1/2 of the time, 5/6 of the time. Remember, the denominator is how many sectors it's cut into. And the numerator is how many pieces have that outcome. So how many C's were there? There was 1 C. So 1 out of 6 sectors have C on it. It has a 1/6 probability of being spun. In 60 spins, how many times would we expect it to stop in sector C? So we're going to do some comparative fractions. We've done this in math power-ups. Remember, we said 1/6 of the time it would be a C. If I'm spinning it 60 times, what did I have to do to this 6 to turn it into 60? I had to multiply it by 10. So I need to do the same operation to my numerator. I need to multiply 1 by 10. So it's likely to occur about 10 times. The probability of an outcome can be expressed as a number ranging from 0 to 1. So instead of a fraction, this would be like kind of comparing it to a decimal, because a whole number 1 means 100%, or one whole pizza. So instead of doing it as a fraction, I could say it's something between 0 and 1. So if an outcome is impossible, that means the probability is 0. There is no chance, 0% chance you're going to get that outcome. If it is certain to happen, like there's no other choice that's definitely going to be the answer, that means the probability is 1, and any other outcome needs to be a fraction between 0 and 1. Like we've seen with A, B, C, and D. Use the spinner below to answer problems 8 through 10. It's just another copy of that same spinner from the first side. What is the probability that the arrow will stop in sector D? Now, this is one of those questions I would have really liked to be doing together in class, because then I could be seeing the wheels turning in your head as you're realizing the answer. Is there a D on that spinner? There is no D on the spinner. So can I spin a D? No. So what is the chance that that's going to happen? 0. It's impossible. There's no D on that spinner, so I can't spin a D. There's a 0 probability that I will spin a D, because that is an impossible outcome. The probability is 0 because the D is not on the spinner. So D is an impossible outcome. And now we finished the first front and back of that first side. I told you guys this is a short investigation. What is the probability that the outcome will be one of the first 3 letters of the alphabet, and why? So the first 3 letters of the alphabet are A, B, C. And I had to stop off in the middle of my serenade. What are all the letters that are on the spinner? I only have A, B, and C on here. So am I likely to choose or to spin an A, B, or a C? I'm 100%, there's a 100% chance I'm going to get A, B, and C, because those are the only choices. Whatever I spin might be an A, might be a B, might be a C, but it can't be any other letter. And those are the first 3 letters of the alphabet. So the probability of me getting one of the first 3 letters of the alphabet is 1, because that is a certain to happen outcome. There is 100% of a chance I'm going to be getting an A, B, or a C on that. Those are the only choices. So the probability is 1, because you have to write really small in that spot. Every sector of the spinner is labeled with one of the first 3 letters of the alphabet, so the outcome is certain to happen. What is the probability that the arrow will stop in sector C? That's a reviewable question that we already answered, because it said every other outcome is going to be a fraction between 0 and 1. So somewhere on this page, we already found the probability that C is going to be spun. So I'll let you hunt for that on your own. Now, we're moving into a new manipulative. We're done with the spinner for now, and then they show you an example of a standard dot cube. A standard dot cube is one that is square, a square, like, you know, it's a square cube. It's a regular dice that you think of, and it has 1 through 6 on it because it has 6 faces. Each face has a 1. Other cubes might have A, B, C, D, E, F on it. There are other dice that are not cubes that have more faces on it than just the 6 that are on a standard dot cube. But a standard dice is a cube that has 6 faces, and it's numbered sequentially 1 through 6. So I've got a 6, I've got a 5, I've got a 4, 3, 2, 1. All 6 are on my dice. So what numbers are represented? If it's a standard dot cube, it has 1 through 6 on it. If a dot cube is rolled once, which number is most likely to end up on top and why? So we already know there's a 1 through a 6 on here. And how many different faces are there? There are 6 faces, just like there were 6 sectors in my, getting some glare, sectors on my spinner. There are 6 faces on a cube. Unlike the spinner, which had 3 A's, 2 B's, and only 1 C, how many times does each number come up on dice? Each one appears 1 time and only once. So there's no number that is more likely to occur than any other number. They all have the same probability of being rolled. So none of the numbers are most likely to end up on top because each number is equally likely to end up on the top after a roll. If a dot cube is rolled many times, about how often would we expect to roll a number greater than 3? So remember, probability can be between 0 and 1. What are the numbers on a dot cube that are greater than 3? 4, 5, 6. So there's 3 numbers that are greater than 3. Out of how many possible choices? How many sides are on a dot cube? 6. So there are 3 out of the 6 choices that are greater than the number 3. So less than half the time, about half the time, more than half the time, none of the time. Probably about half the time. Maybe not exactly. Maybe it's going to be a little bit odd. Maybe you're going to get 5 one more time than you got something below a 3. Or maybe you're going to get a number below 3 an extra time. But probability is what's probably going to happen about 50% or half the time would be a really good guess. Again, on the electronic version of this, you will have a box to enter your answer since you can't circle on the Google slide. We're on the last side of the investigation already. If a dot cube is rolled once, what is the probability of rolling a 7? So think for a little bit. See, investigations are no fun to do virtually because I don't get to have input. I feel like I'm just talking and giving you answers, but normally I'd be able to be taking hands. I'd be seeing the wheels turning. I get to see when the light bulb goes on and you're like, wait a second. There's no 7 on this dice. There's no chance. The probability is 0. There's a 0% chance because it's an impossible outcome. And I really like seeing your faces when you realize something. That's a probability of 0. With one roll of a dot cube, what is the probability of rolling a 1? So this would be similar to How many are greater than 3? How many sides in a dot cube say 1 on it? 1, because 1 through 6 each appear 1 time on each of the 6 faces. So there is a 1 out of 6 probability, 1/6 probability that I'm going to get a 1. How would we describe the likelihood of rolling a 6 with 1 roll of a dot cube? So 6 would have the same probability as a 1. 1 out of 6 sides say 6 on it. How many sides then don't say 6 on it? That would be like doing our power-ups where we are adding and subtracting fractions. Remember, denominators don't change. 100% probability would be a 6 over a 6. 1/6 say 6. Denominator stays the same. So there is a 5/6 probability that I don't roll a 6. So am I more likely to roll a 6 or to not roll a 6? Is it very likely, just as likely as not, unlikely, or I'm definitely 100% certain I will roll a 6? You might 100% certain want to roll a 6, but more likely than not, you're probably going to get a number that's not 6 because 5 of those other numbers are not 6. Only one of them is a 6. The chance of an event is sometimes expressed as a percent from 0 to 100, because remember the whole number 1 is the same thing as saying 100%, just like 0.5 or 5/10 or 50/100ths is the same thing as saying 50%. So the chance of an event, you could say if it's 20, there's a 20% chance of rain, it's more likely to not rain. There's only a 20% chance that it's going to rain. 100 minus 20 is 80. There's an 80% chance it's not going to rain. 80 is more than 20, so the chances are it's probably not going to rain. That doesn't mean it won't rain. There's not a 0% chance. 100% chance of rain means it is certain to rain, or more likely it's raining right now. Like if I pull up the weather app on my phone and it's raining outside, it's going to say 100% chance of rain at whatever time of day I happen to be looking at the weather app. More likely than not, you're not going to see 100% unless that's actually happening, because there's always contingencies where something might not go the way that you planned and it might not work out that way, just like there's probably not a 0% chance of it not raining. You know, there's got to be at least a 1% chance. It could be highly unlikely. It could be a miracle, but it's still possible. As long as there's still condensation in the air, it's still a possibility that we could get rain. The weather forecast stated that the chance of rain is 40%. According to the forecast, is it more likely to rain or not to rain? Now, 100% probability, meaning it's already raining, would be the highest that we could go. So 100% would mean that it's already raining. 40% is the chance that it's going to rain. I want to know what's the chance it's not going to rain. 100 minus 40. There's a 60% chance it doesn't rain. There's a 40% chance that it does rain. Which one's larger, 40 or 60? 60%, it's more likely not to rain. Now, I know this isn't showing up very well on here, so I'm hoping that you guys are listening and working along with me. That's going to be the easiest way for you to continue this. The meteorologist, weather person, said that the chance of rain is 80%. That means that the chance it will not rain is what percent? So you're going to have to subtract that 80 from 100, and then I'm going to let you do that on your own. There's actually 2 problems on here we didn't do. One of them because we did it on a previous page and you need to go back and find it. And then this last one because we're doing it the exact same way as number 17. So at the bottom it says probability experiments are optional. So if I wanted to do an experiment and say, hey, I think that it's a 1/6 chance I'm going to get a 1, but I want to see, how likely I am to get a 1, and I want to roll this then several times. Or I want to know if there's a 50% chance that I roll a number higher than 3. So I'm going to go ahead and roll this dice several times and see which numbers I roll. What you would do is record your answers in something like this. It would be a frequency chart. So I could say, I think that I'm going to get a 1/6 of the time, or I think I'm going to get a 3 through a 5, 3/6 of the time. Then you would roll it and roll it and roll it. And every time that I got a 1, I would put a tally by the 1. Every time I got a 2, I'd put a tally by the 2. Every time I got a 3, I'd put a tally by the 3. And then at the end, I'd see, hey, how many times out of however many times I rolled the dice, did I get a 1? Did I get a 3? Did I get a number that was greater than 3? You would just choose your denominator would be your frequency. So the easiest way would be to make sure you are doing frequencies and multiples of 10, because it's going to be easier for you to figure that out. So I'd say roll it 10 times, or roll it 50 times, roll it 80 times, roll it 100 times. Roll it a multiple of 10 is going to make it easier. There's another one at the bottom too, where it has a whole bunch of different outcomes, and you don't have to go through numbers 1 through 12. This is just if you want to make up your own probability experiment. Maybe if you have a spinner at home, maybe you have a board game with a spinner, maybe yours doesn't have letters, maybe it has colors. You could say, hey, I wonder how many times I'm going to get yellow. You could also do a probability experiment between two possible outcomes. Flipping a coin is a probability experiment. I've got two sides to this coin. One is heads, one is tails. I have about a 50-50 chance of getting heads versus tails, but I might want to see if that's how it really works out. Maybe I want to flip it 10 times and see, did I get heads 5 times? So this is for extra credit. If you wanted to do your own probability experiments at home, you would need to either scan this with an app on your phone, or you would need to turn it in hard copy. But you can attach that to your assignment if you do want to take a picture with the PDF app on your phone and upload that, and then still do the assignment electronically. That's a choice. This is extra credit. It's your own, just for fun, probability experiment. So we're going to continue tomorrow on Wednesday with tables and schedules, lesson 101.